Hi, my name is Simon Bennett. I'm the ZAP founder and project lead, and this is a series of training events that I'm giving to Stackhawk employees about ZAP, which are recording, and hopefully everyone else will find them useful. So some people here may ask questions, but if you're watching this later and you've got any questions, then just please ask them in the section below. So the previous sections, previous training sessions I've done, have all been talking about, the recent ones have all been talking about exploring your application and why that's so important and how you can do that. This time I'm going to move on to the ZAP sites tree and explain why that's important and how you can change it and configure it to ZAP to understand your application better. So I will share my screen and hopefully you can now all see ZAP again. So the sites tree is this thing on the left-hand side of ZAP, and the easiest thing to do will be for me to actually populate that. And what I've got is I've got a set of scripts. So these are simple curl scripts which I'm proxying through ZAP, and they're making a whole load of requests. And you'll actually see, if you look down at the history tree, they're all returning 404s. So I'm completely faking this. But the important thing is not what's behind. It's not the site I'm pretending to explore, but it's actually how the sites tree handles them. So if we have a look at the sites tree now, we will see a hierarchic representation of the application. And the key thing here is that the sites tree is ZAP's representation of your application. And it's important that ZAP can represent your application effectively. So every node in the sites tree, particularly the leaves anyway, represent a part of the structure of your application, and they should all represent different pieces of functionality. And so they can, we build them up based on the URLs and the requests, but really what we're trying to do is target separate pieces of code that's running behind the application. Obviously, we don't know how your application works, so we're trying to guess and trying to get the best representation possible. Why do we do this? We already have the history tab, so we record all of the requests that are made to the application. So we have all of these. So if we want to attack your application, why don't we just use this? Well, the problem with the history is that it's often the case that we'll have loads and loads of requests in the history table, and they are often repeat requests. And if we keep on attacking the same thing over and over again, we're unlikely to have any different effect, and it'll just take too long. So what we're always trying to do is to get that balance between making sure we attack all of your application, but not attack it too much. So we're trying to attack it just the right amount. If we attack too much, it'll just take too long. If it takes too long, you'll get bored, or it'll end up taking days, weeks, however long. So we're trying to attack your application the least we can, but as effective as we can. The sites tree is really a summary of your application. So you won't see a node in there for every request that you make. What you will see is, so the way we choose how to create a new node is we base it on the method. So if a method is different between two requests, then you'll get two nodes. So you can see here we've got a get request to home, and we've got a get post to home. So because one's a get and one's a post, they will be different. Then there's the path. So basically we build up a tree based on the path. So the top, the local host, that's the site level. Then everything between the slashes are going to be nodes in the tree. And then the home element at the end, that will be a node as well, be a leaf node in this case. And then we also use the parameters, but we don't use the parameter values. So if I look at the first request we've made, is a get request to stud site home and a URL parameter a equals b. So that will correspond to this get home with an a in brackets. So the reason we usually ignore the parameter values is that in most cases, in most applications, they don't affect the structure of the application. Think of if you're doing a search, every time you specify different values in the search, you're not going to hit different. You're typically not going to hit different code. You're going to hit the same code every time. So we assume that the values are not as important as the actual parameters. So the second request where we've got a equals c instead of a equals b, in this case, that doesn't create a new node in the tree. But then we've got a request with a equals b and b equals c, and because there's a new parameter b, we assume that this is a different request. So in this case, it'll be this node here, get home parameters a and b. And then we've got another request here with b equals c, and that is logically different from the get with the parameter a and the get with parameter a and b. So each of these three requests are treated by ZAP as logically different, and we will try and attack them separately. And then we've got another one, b equals a, so that will not get us a new node in the sites tree. And then we've got some requests to different pages. So we've got the search and help there, so they will appear as separate nodes in the tree. And another one to about as well. And then we've got some post requests. And in this case, we've got a post request to home with a equals b in the URL and a equals c in the body. So we actually get two a parameters here, and it's the post request there. And again, we've got another one here where we've got post request with a equals b in the body, but not in the actually that one's sorry, that's a equals c, the parameter there, and a equals b and the parameter post body. So they will actually end up as the same post request there. Whereas this is the one where we don't have any URL parameters. We do have a post parameter, so that will result in this node in the tree. So that is how, by default, ZAP will actually create nodes within the sites tree. We're trying to represent the different parts of functionality of your application as best we can without knowing anything about your application. And one thing I should point out is this sites tree, even though I'm showing it in the desktop, it still exists within ZAP when you're running ZAP in daemon mode. So it doesn't matter whether you're in desktop mode or daemon mode, the sites tree will still be there. ZAP is still building up this representation of your application, and this is what we use when we start to active scan your website. So that's why this is so important. Right, so what I'm going to do now is I'm going to talk about the cases where this doesn't work quite so well. So I'm going to create a new session and get rid of all that. And then in my other window, I will run another script and this different set of requests. And it looks like this site is actually a bit bigger. But when you start looking at the requests, you'll see what's happening is we don't have a equals b, we have a colon b. And if we scroll down a bit, we don't have the ampersand, we have a semicolon. So this site is using what we kind of treat as non-standard parameters or characters between the parameters and values. And this is a pain. So by default, ZAP doesn't understand this. ZAP is going to assume that these things are just straight strings. And that is why we actually have, when you look at the sites tree, so home a equals a colon b, that's how it is represented in the sites tree. And that means that where we have home a colon c, so we're actually having too many nodes in the sites tree, assuming that these b and c are actually parameter values. And the other problem here is that when ZAP starts attacking this site, it will not recognize that b is the value. So normally ZAP would start attacking the values and occasionally the parameter names as well, but mostly the values. And in this case, it won't. It'll probably try and attack both of them together. So this means ZAP will not attack this site effectively. And even if you've got, say, a cross-site request forgery vulnerability or SQL injection vulnerability in your B parameter, ZAP won't be attacking it, and therefore it won't find the vulnerability. And if you've got loads and loads of requests with different values that ZAP doesn't recognize as values, you'll have too much here. So ZAP will end up attacking much too much, but in the wrong way. So it'll take too long and it won't find anything, which is not what we want. So how do we handle that? What we need to do is we need to associate different properties with this site. And the way we do that is contexts. So contexts are how we tell ZAP that an application or part of an application works differently from the default. So there's various ways we can handle this, but what I'm going to do is I'm going to right click on, in this case, localhost, and say that I'm going to include it in context, and I'm going to include it in a new context. So we now get this dialog that brings up, and we've got our new context in here. It's called HTTP localhost 8080. And we've got various properties. So here is the regex strings which are including in this context, which ZAP put in for us. You can do these manually, but I never like doing that because there's always a good chance of getting them wrong. We've got exclude regexes as well, so you can exclude certain pages or parts of the site from your context. And then we have structure. And this is the screen we've been focusing on now. So as you can see, we've got URL key value pair separators, URL key value separators, and the same for post. So we can actually tell ZAP that in this particular case, this site uses semicolon to separate the key value pairs and uses a colon to separate the keys and values. Now, as you can see, we've got different ones for URL and post. In this case, I'm going to keep the old one anyway, because these are actually their individual characters, so ZAP will treat each of them separately. If I OK that, we'll see that this has actually changed, but ZAP tries to get things right. In some cases, it might not. You can see down here it's not quite right, so I'm just going to delete all those nodes, and I'm just going to run the script again. Because now we're actually running a script against ZAP and actually knows what to expect. And in this case, you will actually see that we are getting the separate pages, and we're seeing that we are correctly recognizing that we've got A and B parameters rather than the A:B, A:'C. So if your site uses different characters other than the usual question mark and equals in your URL parameters or your post parameters, then that's a very quick fix to make sure that ZAP understands these things more effectively. So that was one case, and I will clear that again. Was that okay for everyone?
Yeah, Simon, I'm curious, what other web applications need custom URL key value separators? When is it applicable to use that?
Very good question. Why would you want to do that? I have no idea. But the problem is people do weird things. We have seen so many weird applications, and so we try not to dictate what people should do, how people should write their applications. We just need to cope with whatever weird and wonderful applications people put together. I really wouldn't recommend using colons and semicolons in this way, but people have. I don't know why. Maybe historical reasons or whatever. So yeah, we just try and make sure ZAP can cope with anything that's out there.
But thank you.
No problem at all. So what I want to do now is run another script, and this one we will see it actually looks like the site's a lot smaller. But when we actually have a look at these requests, we will see we've got a page parameter. We've got page equals home, and then we've got page equals search, page equals help, pages equals about. So this is a different way of implementing an application, and it's something we're seeing more often, and actually see it quite a lot with more modern web applications as well. And this is where a parameter, the value of a parameter, actually does impact what happens. So in this particular case, it looks like this site has a limited set of page values, and those will dictate what happens. The trouble is, ZAP hasn't recognized this. ZAP thinks, well, the values, I'm going to ignore them. And that means we will be attacking one of these pages. In this particular case, page home, home. Yeah, in all cases, this just happens to be page home. It could be, but it could be any of these pages, and it will attack that, but then it won't be attacking all of the other pages. So it won't be attacking help, about, search. And this is a problem. So this is where another case where ZAP doesn't understand the structure and it will not attack all of your site effectively. So what do we do? Again, we need to add this site to a context. So I'll include a new context. And we'll go to the structure set, and we'll see we've got options here. And we can add what we call they're called structural modifiers. So these things modify the structure of the application. And first one we've got is a structural parameter, and the parameter is called page, and we will save that, and we will go OK that. And you'll see that the site has changed now, and we now see the home actually represented in the sites tree. We don't see any of the other pages because we kind of lost that information when we didn't understand the structure of the application. But we just need to make those requests again. And all of a sudden, when I do that, then we will see we get the about page, the help page, and the search page. So what we've done is we've configured ZAP to understand that this page parameter is actually what we call structural. It affects the structure of the application. Once ZAP understands that, and once it sees a new set of requests, it will then go, okay, I need to represent anything with a different value in the sites tree. So we will see it's just the same as, the site is actually exactly the same structure as the original one. It's just we have this page equals about instead of having the about as part of the URL. But having done that, ZAP will then understand the structure, represent it, and then when we start active scanning, we will attack the about page separately from the search page, separately from the home and the help pages. So in this case, ZAP should now understand this properly. Does that make sense?
Yep.
Excellent. Right, so I will now clear that and go for the last case. So this is actually a very different site structure. So it's not like the other ones. So if I look here, we will see we actually got some of these home pages again. Then we've got a company level, and then we've got a whole load of companies under there. And if we look under these, we'll actually see these all have pretty much the same structure. So why is this a problem? Well, the problem is chances are this stuff is coming back from a database. And okay, I've only got half a dozen or so companies, but if you're talking about what we call data-driven content, this could actually be a huge amount. I actually ran ZAP against a Mozilla site, addons.mozilla.org, and basically there was one level per add-on name in that site, and I think the scan took 10 hours, something like that, and that's a problem. That was way too long. And the problem is, if you're getting this stuff out of a database, then if you attack the Apple About page, you're going to hit this exactly the same code when you hit the Facebook About page and the GitLab one, all the other ones. So you're making the same attacks against the same piece of code, and you're wasting time. And if you've got thousands of these nodes, then ZAP will take way too long and won't give you any benefit, because if it finds a problem in this page, it'll find it in this page and this one and this one. So this is basically here, ZAP will attack it effectively, but it'll probably take too long. So how do we handle this? Well, once again, we have to add our site into a context, because that is how we associate different properties with our sites. If I can get my mouse to work properly. So I'll include it in a new context, and then I'll go to the structure. And what we'll see is we can then add what we call a data-driven node. So this is a node that is coming from typically a database. The problem is I've got a specific regex here, and I'm not good with regexes, and they're just far too easy to get wrong. So we're not going to do it that way. But I'm going to OK that, and we'll see the whole site is in our new context. But what I can now do is, whenever we've got things like regexes, we try and make it life easier for you. So in this particular case, I can just pick any one of these nodes, and I'm going to flag it. So to flag it as something related to a context, and in this particular case, I want to flag it as a data-driven node on this localhost 8080 site context. So I'm not including in context, it's already in the context, but I'm telling ZAP that it's actually a data-driven node. And we'll now see we've got this structural modifier here, which is data-driven node. I'll actually call it com just to make it different. And we'll see that there's a regex definition, which all looks sensible. So we get the standard site company and then the usual regex horrors. This is why I didn't want to type that in. So ZAP will just put hopefully the right regex in there, and we click OK, and all of a sudden the site changes. We will see we've now got, instead of each of the company names, we've got com. And so that's a name I gave it, and it's got these double angle brackets. And then we see the structure underneath that. And if we actually select one of these, okay, so it is actually, so the first one's actually Apple, and the next one is GitLab, but it doesn't matter because it's the same piece of, we know in this particular case, or I'm kind of pretending that it's the same code behind all of this site, or this part of the site. So it doesn't matter which of the companies we're attacking, because the company name has actually come from the database. So it's the same functionality behind it. So in this case, we now have a much smaller sites tree, and these nodes represent the functionality behind it, and they don't represent the data. We don't want nodes representing data. We want nodes representing different pieces of functionality, and that's what we've got here. So this can significantly reduce your sites tree. In the case of addons.mozilla.org, I think I've got the scan time down to about 45 minutes, which is much more sane. So if you've got a site which has a lot of data and your data can appear in the URL, then you definitely want to configure ZAP to understand this stuff. Now, I should point out that I'm actually demoing this on ZAP 290, and in 290, we can't have hierarchies of data-driven nodes. ZAP 210, there's a way around that. We can do that, and we actually, in ZAP 210, we have a lot more control of the sites tree, but that's something I will cover at a different time. So, do data-driven nodes make sense?
Yes. I had a quick question. Is all the configuration you showed for setting up the structural modifier for the data driven node, can that be done via the API?
Very good question. Right, so I will fire up a browser and point it at ZAP and have a look at the API. So what we have on the API is we have contexts, and we have a whole set of different things we can do, and we've got a whole load of actions. Now, so what we tend to recommend for most people is that the best thing to do is to set your context up manually within the ZAP desktop. If people start having any sort of problems with automation, I always recommend they go back to the desktop, even if they don't want to actually use it eventually, because it's much easier to basically, in this case, right click on this node and go, okay, so we can see that we've got the data-driven node set up. We know we've got the context, and what we can now do is we can export the context, and we can then, that will export to a file, and then we can import that. So we can then import that context via an action. We've got the import context action here. That is not so effective if you haven't got the, for whatever reason, you don't want to use the desktop UI. So yeah, this is something where it looks like we cannot actually, because I couldn't remember offhand, but at the moment you can do it, but only via a context file.
Excellent. Thank you.
No problem at all. Talking about the sites tree, I did mention in, I think it's the last session, that we have add-ons, things like SOAP, OpenAPI, and GraphQL. All of those can actually populate the sites tree, and any add-on can populate the sites tree, and you can either by just proxying requests, which Apple understand, but add-ons can actually change how nodes are represented in the sites tree, and at 2.10 they've got much more control. So I'll do another session on 2.10, ZAP 2.10 when that comes out, and I can talk about that in a lot more detail. But what I want to do now is, because what I've done previously is talked a bit more about the code, so I will go to ZAProxy/ZAProxy on GitHub, and everything, all the code is under ZAP source main Java in this case, and we can ignore the ch packages most of the time. So then we have these. Before, I think I've mostly gone into ZAProxy/ZAP, but I actually want to go into Paros this time, at least to start with, because under Paros, so there's a lot of, well, not a lot, there's still some old code here we make use of. And if we go into model, then there is sitemap and sitenode. So sitemap is essentially the sites tree that you see in the desktop, or it's the underlying data structure behind it. So that is and it's fairly hefty thing. And then sitenode, these are the nodes within the sites tree. One thing I will point out is this sitemap event publisher, because what we've done is we've created this event publishing mechanism, and wherever you see something event publisher, that means that this is a class that will publish events and actually defines the events that it publish. And so any code within ZAP or ZAP extensions can register as a consumer of these events. So this is just an example, and we can see that we've got site node added, removed, and site added and removed. So these are events that you can consume, you can register for, and then you'll get informed when anything changes in the sites tree. I'm not going to go into a great deal of detail on the code, but I will just mention that in ZAP we do have a similar model structure, and there's a lot more in here. That's where we put all of the new code. And we'll see down here we've got a standard parameter parser, and this you'll actually see is where we define things like, there we go. So here's where we've got the ampersand and the equals. So that's where it's kind of built in that understanding. But we also have these things called, so structural node, site structural node, and structural table node. Now, the structural node is a kind of logical construct. So this is an interface, and it's got two implementations. It's got the structural site node, which I'll have a quick look at here, uses site node. So this is desktop representation. But then what we do have is we have a structural table node, and this doesn't actually use site node. It goes straight into the database. So what we've been trying to do, what we did a while ago, is we have an implementation where we don't hold everything in memory. So at the moment, the desktop and the daemon mode actually hold the site tree in memory. And we wanted to get away from that for particularly large applications, and that's why we have these structural table nodes. This is still experimental functionality. It's not something we've been working on a great deal, but it's something that ZAP can in theory support, and at some point we will change ZAP to actually make sure this works very effectively. But if you want to play around with it, please do, but don't expect it to work perfectly. But do let us know if that's something that you're interested in or something you even want to work on, because we could always do with more people working on ZAP. So that was just a very quick introduction to where some of these things are. But that is all I was going to cover for this session. Okay, well, thank you all very much. Until next time.